Howdy folks, Darren with Fervent Astronomy, and yes, I am a lumberjack. And today we're talking about this, the Viltrox 135 f1.8 LAB lens, the first of that line of lenses from Viltrox. And this is a really, really chunky portrait lens meant to compete with Sony's 135 G Master, but also the Samyang 135 1.8 that came out not too long ago. And because this is an E-mount lens, but also potentially a Nikon Z mount lens in the future, I suppose this might also be competing with the Plena. This is a relatively new lens, and I'm pleased to have finally found a seller in Canada where I was able to get my hands on one relatively quickly after release. I did purchase this lens. This review has no ties to anyone but me and you. But this lens has been, I would say, much anticipated or heralded, and you know, for all intents and purposes, it's a really good lens. In this case, there's a couple of quirks that we're going to talk about. Whether or not they're a deal breaker for you or not, you know, that's up for you to decide. But one of them, I have to admit, I just find really annoying, and that is the hood. I wish I was putting this on, but this is worse than usual. All right, there we go. So, very nice hood. You know, it's plastic, but it's flocked with felt. It's got a nice rubberized ring around the front. That is where the problem lies, because there is inside a little bit of a ledge. And if you look at the manual focus ring here on the lens, there's a little bit of a ramp up here, a little ledge itself. And the two are very close in diameter, and as you can see, they get stuck. That's minimally frustrating. Obviously, once it's off, but just has anything really sort of tiny and almost meaningless ever really just grinded your gears? Because that's what I'm experiencing here. The lens itself is, as you probably heard, quite chunky and really heavy. Like, this is a heavy lens, and it's got an 82 millimeter filter thread with a glass front element that goes almost the entire way. Hopefully that will lead to good vignetting performance, and hopefully a good performance in a new metric that we're going to start talking about, aperture vignetting. So we'll see about that later. And honestly, the lens feels really good in the hand. It is solid, which is unsurprising given how heavy it is. One thing that I do want to mention, it has an actual linear focusing motor in it, similar to the Sony 135 G Master or other higher end lenses these days. And you can hear it. It's quite loud. And what you're hearing there is the actual focusing group sliding back and forth on a magnetic rail, just bouncing back and forth with nothing to restrict it. I'm not sure that's like a great thing, and it does happen with other lenses, so they're guilty of this as well. But there is nothing that locks it in place when the lens is powered off or disconnected from the camera. And it's just like, you know, is going to slide around with as much force as it's given. So please keep that in mind as you travel around with this lens. It does have an actual linear focusing system here, which is to say that that focus group is in a magnetic track and is controlled electromagnetically, and it provides lightning fast, very accurate focus or positioning, I guess, of the focusing element, much as you would see in a lot of higher end lenses these days. So kudos to them for building that in. It is not something that you will find in, say, the Samyang 135 1.8, because that lens actually uses a stepper motor to, and they call it a linear something, but what they've done is they've put a little lens element between a metal pole and a screw, and they use the stepper motor to turn the screw and basically bring that element back and forth. So it's not the same thing. That's why you will hear that this lens focuses a lot faster, because it does. And that's, I mean, it's a high-end component, so kudos for putting it in there. Overall, the whole thing feels really good. I would say it is quite wide, it is quite heavy, but it feels well made. And we've got a decent manual focus ring. It's electronically coupled, of course. One of the reasons for this is that it has to be for that magnetic focusing system to actually work. We've got a manual autofocus switch here. We've got a focus limiter to focus or limit focus for different ranges. And then we've got a declickable or clickable accessory ring. And that allows us to set it for clicky clicky or smooth operation. And this ring is actually able to be assigned to different functions. You can do that in software after the fact. One thing that I actually found a little bit frustrating right out of the box, it has 2 custom buttons, which is great, but these custom buttons are set for a and B, at least in my case, focusing thing, where A is set for a certain point in the focus range and B was set for another point. And when I accidentally hit them, I lost my focus, which was manually focused. So that was a little bit, The other thing that might not be the best for astrophotographers is this LCD display, which is cute. It gives you some information. If you're using the accessory ring as an aperture ring, it'll show you the aperture. If you're using things as for other functions, it'll show it that. So it does have its uses, but it is very bright. So a piece of black tape, if you're doing astrophotography, is going to be a benefit there. On the back, we have the most, I wouldn't say as minute as, say, a Sony rubber gasket, but it's a fairly okay rubber gasket, and it's orange, which is cute. And we'll also see here this port. There's a USB-C port built into the actual ring of the lens, the mounting bayonet there, and that's what you would use to connect this lens to computer, to software, to fiddle with the custom functions. So overall, we've got kind of a chunker of a lens. It's supposed to be quite good. I would say more terrestrial-based reviews I've seen say it acquits itself quite well, so it'll be interesting to see how it performs. Let's go look at that now. Hey folks, welcome to Lightroom, where today we're looking at the Viltrox Autofocus 135 1.8 LAB lens for Sony FE mount and possibly Nikon Z mount in the future, although you can, I believe, adapt this to Z mount cameras using something like a Megadap ETZ21 adapter. Although I haven't tried that personally. I guess I should, because I have one. So here we have some track samples for you. Everything here pretty much is tracked with the Fornax Mounts LighTrack II. Full disclosure, Fervent Astronomy is Fornax's North American distributor, so if you're interested in learning more about that little tracker, by all means, head over to ferventastronomy.com. In the description, you'll also find a link back to the website there that will provide a couple of different things. One is an explainer on ISO invariance, which will explain to you why I'm using ISO 320, although you should also be seeing a little link popping up in the video here for a video that I shot about that. And you'll also find a link back to these samples, full RAW, that you can download, pixel peep, assess for yourself, decide if this is the lens for you. I just ask, they are my copyrighted works. I did have to jump through hoops to do this, so please respect that and just use it for the assessment of the lens. As is often the case, we are testing this lens with the Sony a7R Mark V 60 megapixel camera, very high resolution body, and these are 60-second tracked exposures. So we're really putting the lens through a torture test. There is one over here, which is done with the Sony a7R Mark IV, but my modified version, and well, if you know, you know, so we'll get to that at the end. Let's take a look here. First of all, this is a shot done with a Batinov mask, and this is a focusing aid. It helps you get good focus, and I am going to try and do this as often as possible to see if we can uncover any field distortion. Here you can see this pretty little pattern here. Almost looks like cat whiskers, depending on the direction you're looking at it. This is an indication of good focus. These are called diffraction spikes, and when they align in the middle, you are in focus on that point light source. Brighter stars show up easier, and typically as we go to the edges, we sometimes lose one of the spikes, so it can be hard to assess. That being said, I think we've got lucky down here, and we've got a fairly bright star in here, and here, and here. Now this isn't in the corners, mind you, but this does give us a good indication that we're maintaining focus at least to the bottom of the frame, which means we'll also maintain focus hopefully around this portion of the frame where things aren't showing up as good. Although here you can see this one, we are losing focus a little bit. You can see how the center spike here is shifted to the right. So not every lens on the market is perfect. In fact, none of them are. So even with a design spec saying that there should be maybe a certain amount of focus fall off towards the edges, you will have hills and valleys along that way. So you might find that when you do something like this. And in the corners is where you would expect to see the sort of worst offenders. But yeah, unfortunately, typically when we get out there, we can't see those spikes. So we'll have to assess field distortion another way. But this also does show you that the lens was in focus in the center of the frame. Here's the un-Batinov masked frame at f1.8. So this is going to be the one that I would be most interested in. Popping into the center here, we can see that we've got pretty good roundness in the stars. So our tracking's going good. Got a little bit of chromatic aberration here, a little bit of purple fringing on this star. And it does seem to be directional towards the bottom. I'm not sure if that's indicating a little bit of coma. If we go exploring around here a little bit, we can see that things are generally showing up pretty well. I don't see too much blooming around any of the stars, so we're not dealing with too much spherical distortion as we typically don't with modern lenses. Overall here, if we flip back and forth, we're gonna go f1.8 to f2. You can see that there is a bit of a darkening in the center only, and if you look at the histogram, you can see that the left side of the histogram doesn't move. This is the shadows and blacks, but we do lose a little bit on the right side of the histogram. So you can see how the histogram shifting to the left on this side, but it's holding steady here on the left portion there. And this is indicating that we are losing a little bit of that center illumination. We're not losing anything in the corners, so stopping down to f2, we're getting more of an even illumination. And by doing so, we might actually be improving our image quality a bit. Just gonna pop into the middle again and switch back and forth. And you can see that we get a little bit better contrast when we do stop down there. And if you look at this star, for instance, we're losing a little bit of that chromatic aberration and maybe a tiny bit of blooming. So some of this illumination in the middle at wide open is possibly going to be reducing contrast, but it doesn't seem like a big deal. There is vignetting here if we look at the navigator, of course, but it's not actually that bad. Things seem still pretty decently illuminated in the corners, and it's not encroaching too deep into the frame, so that is really nice to see. And now we're going to look at the corner here, and we're going to assess the astigmatism. And yes, this is called astigmatism. This is not coma. I do hope to eventually do separate explainer videos on all of these aberrations, and if I do at some point in the future, at the top of the frame, you might find there's a little link that will bring you to one of those, but essentially astigmatism is the inability of the lens to focus a pinpoint into a pinpoint, and it gets stretched out in two directions. Tangential astigmatism follows from the edges to the center of the frame, and sagittal astigmatism is perpendicular to that. So it will kind of look like it rings the frame, and tangential will point directly towards the middle of the frame. So here where these stars are stretching out to little tadpoles, that's tangential astigmatism. And these little spikes here are actually indicators of sagittal astigmatism, in addition to this purple fringe, which is chromatic aberration. We will touch on the sagittal astigmatism in another sample because it's a little bit easier to see. Here in the top right, we've got very similar type of astigmatism to the top left. Bottom right, maybe changing shape a little bit, and bottom left, maybe closer to bottom right, but overall, they are not wildly different. One thing that I did notice while doing that is that there is some field distortion, as we touched on at the beginning there. Now, if you take a look at these stars here, try and remember kind of how big they are. If we pop over here, while we are dealing with that astigmatism, we can see that things are starting to defocus a little bit. Stars are getting bigger and a little more out of focus looking, at least to my eye. If you pop into the center again, they're a little bit tighter. Pop over to the edge here. Again, they're getting a bit wider. So there is a little bit of field distortion happening there, which is part and parcel to having a lens that's made out of curved glass elements. One thing that isn't showing up really to my eye too much is coma, maybe a little bit. So what coma actually is, or chromatic aberration, it's an aberration where you'll get a loss of contrast on one side of a star, or rather on a pinpoint of light, So here, you see the star, we've got a really defined edge here. As it gets a little bit fuzzier to this side, and you'll notice this one's the same, and this one, and this one, and this one. That is actually an indication, I guess, of a little coma. Since the fuzzier part is pointing to the edge, we would call this external coma. And this is named after coma in comets. You know, comet gets that fuzzy halo around it, and since it's traveling through space and the solar wind's acting on it, it blows out to one side. So this is where the name comes from. So there's a little bit of coma. This is separate from what we would consider astigmatism, but there is that little bit of fuzz. It's not too bad, but it is there. And yeah, it is showing up here even in the center of the frame a little bit of that external coma. And that's why when we stopped at this star at the beginning, you'll see that the fringe and everything is mostly on this one side. It's suffering from a little bit of chromatic aberration that's imbalancing it. It's just kind of what happens. So that's kind of the normal stuff, the standard stuff, but we're going to be adding in a new metric here. Hopefully you'll see what it is right off the bat. This frame isn't great overall. There were some clouds coming through here, but we're going to start talking about aperture vignetting. And if we zoom in here, we can see that we've got a star, and it's got almost this bilateral symmetry where on one side it's got this blooming, on the other side it's got the blooming, and it's almost got these sort of dark chunks taken out of it. This is the in-focus manifestation of what you would normally consider cat's eye bokeh on specular highlights in a lens like this, a portrait lens, when using it for normal photography, terrestrial photography. Which is to say that when the actual light from the star is coming in, it's literally clipping on the aperture of the lens, and that is leading to this situation. I'm assuming it's somewhat linked to diffraction, but in any case, that's kind of what's happening there. And as we stop down, you'll see that we get some changes happening as things diffract a little bit more, and it does then even itself out a little bit. This is at f2.8, so you can see you got a bit of a more even rendition here, although you're still having all of this bloom happening and the loss of contrast associated with it. So this is going to show up when you have bright stars near the edges, and it's going to be progressively worse the closer to the edge or corner you get. So please keep that in mind. If you're going to be putting brighter objects towards the periphery here, you might need to consider doing a panorama and then chopping out this portion and replacing it with a portion from another shot. Now let's go into the middle here and let's cycle through. This is f1.8, f2, f2.2, f2.5, f2.8, f3.2, 3.5, and f4. Quite dark. We'll go reverse here, zoomed out, so f4, 3.5, 3.2, 2.8, 2.5, f2.2, f2, and f1.8. And if you watch the navigator here, as you stop down a little bit, and if you watch the histogram actually, I think to f2.2, you're still maintaining peripheral illumination. You're just darkening the center and you're leading to a little bit more of an evening. But once you're at 2.5, the histogram is shifting to the left. So you're just getting also a lower illumination in the edges and corners there. So keep that in mind if you want to stop down. Next, we'll look in the corners here. So this is 1.8, f2, 2.2, 2.5, 2.8, and you'll notice it's starting to get darker, but we're not really changing the astigmatism here. It's not really tightening up. Typically, sagittal or tangential will tighten up as we do this. And in this case, since we're seeing mostly tangential, that's what we're dealing with. 3.2, 3.5, f4, it really just doesn't help at all. Now I do want to come back over here to these shots where we had the aperture vignetting, because I did notice, and we'll pop into the middle here. Now, mind you, there's a little bit of star trailing starting here. That's my bad. I must have kicked my tripod or something at some point. But if we go into the corners, we will notice that at this particular moment in time, when this lens was focused, it was showing a little more sagittal astigmatism. So we've got that tadpole shape, but now it's kind of got a flatter head and these little wings out the side. So this is a sagittal astigmatism. This is a tangential astigmatism. And if you pop into the center, you'll notice that, things look still in focus. So this can be a really minute difference between this shape here where we've got the sagittal and this here where we're mostly dealing with the tangential. So just like a subtle focus shift. So keep that in mind. You might have to deal with tangential and sagittal astigmatism depending on exactly how the lens is focused. And here we've got the Pleiades, starting to see that, even out here with these stars that are of, moderate brightness, we are starting to get a little bit of that split in the middle. We are starting to get that aperture vignetting happening. Take a look at this sample really quick, because this is Andromeda, of course, but we've got a different star here in the corner, and we've got some different astigmatism as well. Here, the star is not as bright as what we were dealing with over here, because I think this was Jupiter. Pretty sure that was Jupiter. Here, I'm too lazy to look up what this one is. We got that aperture vignetting happening. We got a little galaxy in the background, but we are getting some weird looking astigmatism. And here we've got even more defined sagittal astigmatism, and I'm going to assume we're out of focus in the center a little bit. Yeah, so here you can see we're out of focus in the center. So things are a little bit blurrier, right? I think we can clearly see that. So what's happening here is as the corner gets more focused, remember we did have some field distortion, we are going to put these stars in focus more. And by doing so, they are going to display that tangential and sagittal astigmatism more strongly. So if you are thinking of, trying to counteract field distortion by maybe focusing for middle ground here to try and get an even focus across the plane of the image, I would actually recommend against that unless you want to have to deal with that astigmatism. And elephant in the room over here. So this lens, much like the Viltrox 16mm f1.8, for some reason has an internal infrared light source. This is the lens that's doing this, and as you can see by the fact that there's ghosting, it is a really bright light, and I don't know why that is. This is only going to be relevant if you have a modified camera and are attempting to use this lens for more hydrogen alpha work. You can't. You just can't with this lens. This is a 30-second exposure. I cranked the ISO up to 12,800, but given that the A7R Mark IV's second base ISO is 320, this is exactly what you would see with a 30-second shot at 320 if you increase the exposure here in Lightroom as well. I just was doing this as a cheap and lazy way to visualize it. So that's really unfortunate. One of the things I like using 135 lenses for are emission nebulae and like different parts of the core of the Milky Way with a modified camera. So this lens just can't do it. All right, let's come in here and we'll pop into the develop module. We will see what kind of corrections we have or do not have. So let's take a look. We got some chromatic aberration here. Remove chromatic aberration never works. We'll come up here, grab the dropper, we'll defringe that, and that purple fringing is gone. You'll see it's similarly cleaned up here from these stars as well. And if we enable profile corrections, unable to locate a matching profile. So Lightroom does have a profile for this lens. We'll enable the profile corrections and disable them. And you can see this lens has very, very low distortion, very slight pincushion distortion, where the center of the frame, you can think of it as being pushed away from the viewer. Enabling the profile corrections will transform the image to basically pull that center towards the viewer. And if you look at the corners, they're not going to move. The stop edge is going to lose a little bit of field of view. The short edges there may be a slight amount, but overall, that's not an extreme transformation at all. If we just look over here and scale down, you can see the shape change here. So you can see it's basically just stretching the image mostly vertically and a little bit through the mid frame here horizontally. One thing that I am noticing is that the vignetting is not being completely corrected. It's helping, but it's still quite dark in the corners. So you might have to come here and do some manual fixes, although still quite dark there. So that might require a little bit more attention, but overall low distortion, good to see. And with that, let's pop out of Lightroom and wrap it up. Well, what do you think? Not just an oversized maraca, pretty decent astrophotography lens, right? As you would hope and expect. I can tell you, not everything that is meant for portraits is automatically going to be good for astrophotography, especially when things like bokeh are in contention, or out of focus character, that type of stuff isn't necessarily something that is relevant to astrophotography. So in this case, there are a couple of things that maybe hold it back in some ways. It's not perfect, but that is just kind of how things are. Nothing is perfect. And, in a lot of cases you get what you pay for. Lens is still very well made and fairly affordable. So it's a good value choice there. I think you get a lot of use out of it that way. But there is some astigmatism. whether you're willing to put out, an extra grand or whatever it is to get a lens that doesn't suffer that astigmatism, that's up to you. If it's a problem for you, now you know. I would say the thing that I find the most unappealing about the lens personally is the fact that it's got an internal infrared light source. I don't know what is going on in there that it has that. I have learned that the Viltrox 16mm 1.8 has that same type of issue, and there are lenses from other manufacturers that do have it. I'm guessing there's some type of optocoupler that is meant to gauge the, distance of the focusing system, or it's measuring something, but unfortunately that makes it kind of a no-go for modified cameras. So if you want a lens to use with a modified system, this is not the one for you. It's just not going to be usable at all. That said, overall the star field is pretty good. There is a bit of astigmatism in the edges and corners. It's not a huge deal. It can be dealt with, but it is something to keep in mind if you're looking to maximize image quality. That being said, the price is right. Like, it's quite an attractive price, so I'll leave the choice up to you. Of course, that's what this review is for. So I hope you found this interesting. If you found it interesting, you found it helpful, I hate to do the YouTube thing, but it is an unfortunate fact of life that if people don't like the video or comment, for instance, fewer people end up seeing it. So if you thought this was worth clicking a button, please do. And if you want to leave a comment, please do. One of the things that brightens my day is being able to engage with people, chit chat. I know there's some of you that already have experienced that and send me questions via email and stuff. I love it. So please leave a comment if nothing else. And yeah, hopefully we'll see you in the next one. Take care.